my pants and twist my fingers with my hands. While all these rap niggas wanna be bloods, never see him in the hood.
Hi guys, my name is Nako Nakatsuka. I'm a 4th year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. Limiting reactant calculations employ the knowledge that we have about balancing equations, calculating molar mass, converting masses to moles, all the things that we've talked about up until now. In order to have you visualize what these calculations are all about, I drew this very simple diagram for you. So let's say we're reacting A, which are these white balls, with B, which are these black balls. And in order to get C, the products look like this. Kind of a weird looking Mickey Mouse, okay? And so C involves using 1 black ball and 2 white balls. So the limiting factor here is the amount of one of these reactants. So we can make another one of C, right? Because this just involves 2 black balls and 4 white balls. But now let's look at how much we used up. So 2 black balls and 4 white balls. So from here you can see that we ran out of B, no more B. But we still have 2 A's left over. But just because we have 2 white balls left over doesn't mean that we can keep creating more of these Mickey Mouse balls, because the limiting factor, or the limiting reactant, is B. So basically when you look at a chemical reaction, we need to figure out which of the reactants is limiting in the formation of the product. So if a reaction runs out of any reactant, then that reactant limits the amount of product formed, and it's called the limiting reactant. So, in order to solve these problems, there are some basic steps that you need to take. I'm going to write them out for you on here, but you might want to review it again when I actually start solving a problem for you, because these are just the basic steps. So, to solve a stoichiometry problem, first, identify the reactants and products. So that's pretty straightforward, right? In this case, A and B are the reactants, C is the product. Write a balanced equation for the reaction. So what that means is, if you look in the chapter where we talked about balancing equations, you have to make sure you have the same number of elements on the reactant side and the product side. 3, calculate the molar mass of each reactant and product. So again, that's really straightforward. If you have something like CO2, you go to your periodic table, you know the molar mass of carbon, you know the molar mass of oxygen. This is like 12 grams per mole. This is like 16 grams per mole. Make sure you multiply this by 2 because you have 2 atoms of oxygen, and the total of that will give you the molar mass. So do that for all of the reactants and products. 4, convert known masses of the reactants and products to moles. So we did this before too, so you should be familiar with this. And 5, compare the calculated moles right here in step 4 to the required moles. And this is a very important step because this determines whether there's a limiting reactant. So in step 5, decide what the limiting reactant is. And then number 6, based on the moles of the limiting reactant, then calculate the moles of the product that can form based upon the limiting reactant moles. Then convert this number of moles of product to grams, and this is actually called the theoretical yield. What the theoretical yield means is that based upon the given amount of the reactants, this amount of product should form. So it's theoretical. So right now this is just a bunch of steps. It probably doesn't make too much sense to you, but this is a really good list to follow when you actually start doing the calculations, and I'm about to show you an example of that.
I'm about to pull a Suge Knight and press the issue on sight. The real bloods need a check, go we on your ass. I went to sleep flamed up, but I woke up in my polos.